Hello, my name is Tim Garretts, and I'm the robotics director at Sarah Hines' house. Today, we're going to be talking about 3D printing. Now, there are a lot of topics in 3D printing, but what I'm going to cover today is the basics that you can use in any design software. So there are 5 basics, and I'm going to show them to you right now. So these are the 5 basic operations whenever you're doing 3D design. First one is scaling. That means making something larger or smaller. Translation, which is moving something back or forth or up or down. Number 3 is rotation, which is spinning something around. I'm going to have examples of each of these to show you in a minute, but I just wanted to cover them right now on a list. Now the 4th thing is addition. We're going to take shapes and we're going to add them together to combine a larger shape. And then number 5 is we can subtract one shape from another to give a different shape as well. I'm going to show you some examples of these right now. So first we're going to talk about scaling. Now scaling is making something bigger or smaller, and whenever we are doing design we can use all 3 dimensions, x, y, and z is the height. So here we have a basic cube. So if I want to turn this into this, then I scale down the z, I flatten it, and I stretch out the x and the y. So this can work with a lot of different shapes as well. Here's another example here. This is called a gimbal, and it's just a couple of rings and they can spin freely. Now, one thing to note is that this was actually printed in one piece. They're captured inside. These parts are not going to come out. But how this was made is you take this one basic shape, almost a ring, and then you make it a little bit smaller, put it inside that one, make that one a little bit smaller, put it inside this one. Now what we did whenever we designed this is just like this. We scaled it in X and Y to make this total shape. The next topic we're going to talk about is translation. So what translation is whenever you move something back and forth. So it can move Y up and down, X back and forth, and Z up and down as well. So with scaling, we were changing the size of the object. Here we're changing the location of the object. Now, I have 2 examples here to show you of how you would use translation. So this right here is chainmail, and it's really cool to play with, and it's sort of flexible, but it's made out of little hard parts. And if you look at this carefully, you'll see it is the exact same part. Here, 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 here. It's about 60 of the exact same part, and how it's assembled is you take this one piece and then you translate it down here, translate it down here, translate it down here. Same thing across, translate it across, and you have the exact same shape, 60 of them in a very specific location. So this is an example of translation, how you might use it in an actual design. I have another example where you might use translation. Now this is where you want to make multiple shapes that are the same. This is a puzzle, and I'm going to take it apart and show you that this puzzle is actually made out of 6 identical pieces. I'm going to line them up. So if I wanted to print these, I could design 6 separate things, but instead what I do is I design one, and then I take it, copy it, and translate it over. Copy it, translate it, and then I can print 6 of these at the same time. That's another technique that we use in 3D printing. So the next topic I'd like to talk about is rotation. So we've talked about changing the size of something, that's scaling, changing the location of it, which is translation, and changing the rotation is turning it around the circle. So this right here is a gear, and it's a gear made up of little gears. It's called a planetary gear. So this was printed in one piece, and like the gimbal, it's also captured. These gears aren't going to come out. But how we design this is we take one of these little gears, and these are all the same. One gear, we rotate it around here, we rotate it around here, rotate it around here, put another one, rotate around here, put another one. So we can use that to design multiple pieces that are the same as well. We use rotation sometimes to design circular objects as well. So here's a cylinder as an example. Our next topic we're going to talk about is addition and subtraction. So now that we've placed the objects where we want, now we can add them together to make more complex shapes. So here is a keychain. Basic keychain, and we've got the Sharp logo on it. Now, Sharp stands for Sarah Hines Advanced Robotics Program. That's the robotics program that we have with a bunch of robotics teams on it. And here we have our logo, shaped like a bow tie. Now on this one, you see I added it. It's not very thick, but I added it on top of the keychain. All right. Now I'm going to compare that to this one, where I hope you can see, but I subtracted it from the keychain, so it is inset in it. So these are the kind of operations that you can do to make your own designs. And here, as a little bit simpler design, how do we make this empty cylinder, sort of like a cup? We have a cylinder, and then to make it hollow, we subtract a cylinder from the inside. We can make all kinds of shapes just with these 5 operations: scaling, translation, rotation, and addition and subtraction. But one of our considerations with 3D printing is that it's not very fast. So it's good for making custom things, but it's not for making large things and lots of things. So as an example here, these are all using about the same amount of material. So this is all about an hour of printing. It's not very big, as you can see. So this is the same amount of plastic as this, the same amount of plastic as this. Now, this is where scaling can really come into use whenever you're doing a design, because it is faster to make a small version of what you want to make before you make the full-size version. So I'm going to give you an example of one of the sculptures I made. So this is one of the things I do. I make 3D printed sculptures and light them up with LEDs. So this right here, pretty cool sculpture. I really like this shape, and it really diffuses light really well. But this one's a small version, and this one I believe was about 4 or 5 hours to print this one. I wanted to make sure that the shape was right before I made a full-size version. So here's the full-size version. This one took about 24 hours to print, and this one actually has lights inside it, so I'm going to show you that next. So this isn't exactly the best light or the best situation to show off these lights, but it'll give you an idea of the kind of colors that you can get whenever you use this clear plastic to diffuse LEDs. Those are the basics of 3D printing. Now you'll note I didn't mention any software in here because these are general principles you can use with any design software. But the software we do use for elementary kids is Tinkercad. If you want to experiment around with that, go right ahead. That's what we use in our lab. And for the high school kids designing for the robotics teams, we use SolidWorks. But these basic principles will get you started in any CAD software. So thanks for joining me today and talking about 3D printing. Thanks.